Good morning, friends. Let's continue our discussion about read-write lock. So in the previous videos, we have seen that how we can implement a very basic read-write lock. So we have defined an interface which has got lock read, lock write, and unlock write. And we just maintain three variables. All the three are integers where we keep the counts of that how many readers are there and how many writers are there and how many write requests are there. Based on all these three counters, we were able to implement a very basic, all this like of read locks and write locks, where we actually maintain that whenever, but the basic concept still remains same, that if there are, if there's no thread which is currently writing, in that case, there can be multiple threads which can read it at the same time. There's no need of any lock when there is no thread writing on it. But if there is any thread which is writing at the moment, and only in that scenario, there cannot be any other thread which can read or write it. So this is the basic concept. And here that's why we maintain this write request as well, because writers get more priority than the readers, that whenever even there is any write request, as we have done in this lock read, that whenever there is a writers or if there is any write request as well, then the lock read has to wait. Only when there is no writers or there are no write requests at all, only then the read access is done. And we have implemented this in the same way, and we also wrote some test cases where we increment a counter by multiple readers and writers, and it's all thread safe. So going forward in this video, now let's continue our discussion about reentrance. The concept of reentrance is like this, that suppose if a thread has already acquired a lock and it again wants inside a method, there is another method call which again requires to acquire the same lock again. In that case, it doesn't have to wait it, because internally how it works is that the JVM has got internal counter associated with each of the lock. And whenever a thread acquires a lock, that counter is increased to 1. And whenever that thread releases that lock, that counter is decreased to 1, is decremented to 1. So it means that if the same lock is acquired and we are trying to, the same thread is trying to acquire the lock once again, then simply the counter would be increased. So it's better to look at an example. So it means that we can do something like this on a single thread, that it acquires a lock on foo. Foo is an object, and say do something, and acquire a lock on foo again. Note that we haven't released the lock that we previously acquired. The first time when we acquired it, after this, we haven't moved out of that synchronized block or of that or called lock.unlock. In that case, if it still tries to acquire another the lock on foo again, it's allowed. This is called reentrance. Just looking at this example here, for example, there's an object lock here, right? Okay, so there's a thread which comes here at this point, and then it's called this synchronized lock, and it is allowed to by the OS thread scheduler, it's allowed to access this lock. Once it's acquired this lock, then it's runs the code inside it, and inside this lock block of this code, there's another method being called here, do something, and this do something is also synchronized on the same lock. So in that case, the thread which has already acquired the lock here, it doesn't have to wait or do anything, because it is allowed to enter this lock at this point, because it all maintains it's done by the JVM that it has called as internal counter. So at this point, say the counter is increased to 1. At this point, the counter is increased to 2. And when this thread, which is holding this lock, it exits at this point, then the counter would be reduced from 2 to 1. And similarly, once it comes back here, and after that, it executes the code here again. And once it leaves this synchronized block, after this, the counter would be decreased to 0. Because 2 times here, 1, 2, and then again, once it releases here, it decreases by 1, and then here it also decreases by 1. And finally, when the counter is reduced to 0, in that case, it says that the lock has been released by that thread. So this is how it all happens, and this is called reentrance. So the follow-up question on this is that we have to implement the read reentrance, which means that a thread is granted read reentrance if it can get read access. First of all, of course, if it can get the read access, only then it can go for the reentrance. So it means that if the thread has already acquired a read lock, and there are no other threads which are writing or reading, no other thread writing or created a write request. And if it wants to acquire the same block again for the read access, it should be allowed. So this is what we are going to implement in our next video. So see you all in the next video.